Greetings and welcome, friends. We started a new chapter the t'other day. We were talking about slope-intercept form, which, in case you don't remember, is y equals mx plus b. The nice thing about slope-intercept form is that just by looking at the equation, you can see what the value of m is and immediately determine the value of b. What does m represent, friends? M is the slope, like M for mountain slope, and B is the Y-intercept, which doesn't even have a B in it, but that's fine. We're fine with that. So we've got the slope and the Y-intercept, and we started the task the other day of, instead of starting with an equation and then finding the slope, Y-intercept, and graphing it, we did it in reverse. Back it up. Right? We started by being given clues, and then I had to find out which equation would fulfill those clues. So for problem 4, they said the slope was 0, that means m equals 0. They said the y-intercept was 5, that means b equals 5. And if I want to write the equation of the line, there's only one line that will have these facts true about it. I said that the slope and y-intercept are like the DNA of the line. That if I know these two things, there's only one line that will ever look like that, and it's this, y equals 0x plus 5. Another way I could write that, because it's got a slope of 0, is going to be y equals 5. That's a little simpler there for us. What does that line look like when it's got a slope of 0? It's a horizontal line, so it'll be like this. Yep, you know it was one of them. So let's see. The slope here, m, is -7, and the y-intercept is 1. And all I got to do is plug it in to the slope-intercept form. So y equals -7x plus 1. Right? There we go. And slopes can even be fractions. Actually, we love fraction slopes, because slope we think of as rise over run, so this would have been like down 3 and over 4, right? Down 3 and over 4. And the y-intercept is -6, and then we plug it in to the slope-intercept form. So my equation is y equals -3/4 x minus 6. Now, someone I believe asked the other day, why do we leave these in terms of x and y? And that's because as an equation, it represents all combinations of points x1, y1 that will make the equation true. There are infinitely many points on the line, and there are infinitely many combinations of x and y that will make this equation true. So that's why we leave them generically as x and y. If I plugged in numbers there, I would be talking about one point and not a line. All right, let's do some scrolling. Here we go. Oh, pick it up a notch. This time, I've got to find the m and the b from the graph. So to find the slope from the graph, I want to pick what are called two lattice points. They happen to pick some pretty great ones for us. Lattice points are where it crosses the grid, right on the crosshairs of that grid. And then find out how much do I have to move to get from one to the other. So the rise from this point would be going down, looks like down 1 and over 4. Yeah, so m is going to equal -1/4. So there's my slope. What's the y-intercept here, friends? Yeah, the y-intercept is where the line crosses the y-axis. So b equals 3. So y equals -1/4 x plus 3. All right, gentlemen, settle down over there. I know we're all excited about this. So here's my equation. I had to find the equation by reading it off of the graph. So for these two, once again, I don't have to use the points they picked if I can find another lattice point, right? Another point on the grid. It looks like I've got a few to select from. But whatever ones I use, my slope will reduce to the same fraction. So it looks like to go between any 2 points here, I could go up 2 and over 1. So my slope is 2 over 1, or just 2. You could also just call that 2 if you'd like. And that is the same thing as if I picked other points, right? Up 4 and over 2. 4 divided by 2 is still 2, right? Or 6 divided by 3 is still 2. What's the y-intercept here? Where is it crossing this? Yeah, -2, -2. So let's plug this into the equation. Y equals m. Instead of m, I'm going to write 2. X and plus b is -2 this time. All right, so that's not that bad. Another way, by the way, that you can find the slope is using the slope formula. M is equal to y2 minus y1 over x2 minus x1. We talked about the slope formula a while back. You need to smuggle that in your brain box for a test, by the way. That's not something I'll give you. That's something you smuggle in your brain box, like I said. So if I wanted to find the slope, oh dear, my tablet shut off. Here we go, I'm back. I like my little mosquito when he's back. Yeah. So let's see. Here I've got a point x1, y1, x2, y2. I just want to show you that slope works off of the graph before I get to these last couple of problems. Maybe one problem, maybe two, I don't remember. So the slope, m, is going to equal y2 minus y1 over x2 minus x1. Let's simplify this. 2 minus 3 is -1. 4 minus 0 is 4. And I do, in fact, get a slope of -1/4 for m. All right, so the slope formula also works if you happen to have the coordinates of the points. That works just dandy. And that is what we'd need to do on these last two examples. Here, I don't have a graph to work off of. So this is like if you're a crime scene investigator, all we've got is 2 points that, right, the trajectory of the bullet happened to pass through, and you're like, I got to figure out this equation. I need the m and the b here. This is what we do. We label these x1, y1, x2, y2, and I can find the slope m using the slope formula. So y2 is -5 minus 7. So 100% of you guys should probably be writing these down, except actually I know one person not. One person done figured this out, even though I didn't show it to you Friday. 0 minus 2. So I plug it into slope intercept, or slope formula, my bad. -5 minus 7 becomes more negative, that's -12. 0 minus 2 is -2. What's that become? M equals +6, that's right. Now the other thing I need to find is B. B is the y-intercept. That's where the line crosses the y-axis. There are some clever ways I'll show you today as to how we could find the y-intercept, but these problems, secretly, were like easier ones, if I knew a trick. Remember back when we would graph standard form using Intercepts method, I would find the y-intercept by plugging 0 in for x. And notice this point right here happens to have 0 as its x coordinate. So that actually means that B is going to equal -5. That point will be on the y-axis, and it's on my line, and that seems like pretty much the definition of an intercept, right? It's where the line crosses that other line. So my equation is y equals 6x minus 5. We found our culprit. The only line that happens to pass between those 2 points will have this slope and this y-intercept and will look like that. All right, let's do this last one together. It'll be good. So label my points. Actually, tell you what, did you know you can label them this way as well? x1, y1, x2, y2. If I'm calling this point 2, I can't call part of it point 1 and point 2. I have to lock it in. But once I call it point 2, that doesn't matter. I can just label it as such. So let's find the slope. the sloppy slope. M is y2 is -4 this time, minus y1 is another -4. Careful of your double negatives there. X2 minus x1. If you call this point 2, then you just have a little switcheroo there. It'll be fine. -4 minus a -4. What? What? -4 minus a -4? That becomes a plus, and -4 plus 4 is 0 over 2. 0 divided by 2, what's that going to be? That's a slope of 0 divided by 2. I have 0 pizza to divide amongst my 2 friends. Everyone, tell you what, is getting 0 pizza. Yeah. Not bad. What is the y-intercept here? Yeah, because the y-intercept will occur whenever x is 0. So like so. So what is my equation of the line? Precisely. Right, if you did write y equals 0x minus 4, 0 times any number is 0. So y equals -4. All right, thanks for watching, Internet friends. Have a great day. Bye-bye.